everybody to the second episode of what it feels like when you can respond in real time. So this is a slightly more technical discussion about real-time predictions and how it feels when you can respond in real time. The main presenter today is going to be Dr. Jay van Sale, ably assisted by Dr. Eric Newby. Jay, over to you.
Actually, Eric is the lead. I'm the assistant. No, the way it works. So what we figured we're going to do today is first just discuss some of the concepts and get some feedback from the audience around, and I know that we normally have our meetups where we kind of present something out of the box. And the idea today was to first discuss a few topics. And then what we can do is we can then show you what it looks like when you run a real-time simulation. And we're going to show you kind of stage one of a simulation. This is the crude version that's not going to do anything fancy other than showing you how you would track the interactions from basically a creation point of view and what the responses would look like if you had to look at it on the dashboard. So anybody who's got a view on, what this would mean to them, maybe we should start there. What does it mean to you as an individual to have things done in real time, especially from a technology point of view?
Instantly relevant.
If you want an instantly relevant life insurance policy, it means that the moment you die, it determines if it needs to recommend what the actions are going to be. Or it could be on the other end that you're busy driving, and maybe on your car, and as you turn the steering wheel, it detected in real time that there's a potential obstacle that you're going to hit, and it will warn you and maybe shake the steering wheel or even correct it for you. So kind of two opposite ends of the spectrum, but relevance, yeah, that's great.
If you're interacting with anything, if you're getting feedback while you're interacting, that's the most likely that you're going to, because you're engaged, you're involved in it.
Okay, so what kind of feedback?
Whatever, if you're trying to fill out a form, like an online form, and you've forgotten something, and it might cause a delay. If you knew that, you might not have known what that information is or how to fill it in. Okay. You might think, okay, I don't know what it is. Let me go and find out. And you might never come back to the form.
But is that so think about it, would you need, and this may be also for a broader question, would you need a predictor to tell you that you've captured something wrong on a form?
Yeah, you might not know. Some forms are 4 pages long, and you might have forgot the first one.
Is it an ultimate predictor to kind of remove the form entirely?
Well, if you could solve that, you could.
I'm just messing.
Boiling the ocean, but yeah, 100%.
Yeah. But I think the question is more around, the trade-off then, because the thing is that if you're going to give feedback that's instantaneous, and there are some things that can be detected fairly deliberately, would the feedback system need to be a predictor? Because I think sometimes people think that everything can be automated through predictions, but maybe doesn't have to be, because it's computationally too costly and it's going to take too much effort. So if you wanted to check that you've put in the right date, or you have put in, correct details, or, you are going to a site to purchase something highly specifically and you've already searched and picked it, it means that immediate feedback, I think, still just need generic rules. And there's some genericness about kind of people that are highly deliberate, highly specific, get something back. And then it's all the periphery recommendations that then kind of kick in, because then what you want feedback on is say, well, people who do this are most likely to respond to an offer that is related to what they've bought. So I think that, I'm not sure if anybody else has got a clear view on how they would draw that distinction between when something is predictive or when something is rule-based.
Jeff, for me, the real time is about nudging somebody to do something in real time and getting them. So ideally, if you're a retailer or a telco or somebody, you want to nudge them while you've got them, while, as Rob says, they're engaged. You want to nudge them to do something, and preferably you want to nudge them to buy something or remind them to purchase something and increase the revenue streams. That's got to be a huge benefit of a real-time engagement. You've got the oak, you make a suggestion, a recommender, whatever you want to call it, and you get him to do something positive that's good for business.
Yeah. So Brian, that's a great, yeah, I think that's definitely a great way to look at it. So let's just think about, we often use the kind of way to describe that into like a 4-stage view. If you had to think of people that you know nothing about and that you are going to bring in as leads, and you want to nudge them, it means that you know nothing about them. You might have acquired a list from somebody and you've got no understanding of what it is that they're going to be doing. It means that you need to have a real-time view of a cold start intervention or a nudge. Once they enter your world, then the second stage, it means that they connect with you and they engage and they provide you with information. And a lot of the generic interactions will be checked through rules just to make sure that people participate. But then once they enter and you know more about them, you can have probably an intervention and a message and a nudge that is far more realistic, because now you know a little bit more about them. And then once you convert them into a customer, you then have an entirely different world, because now what you have is you got the people that are new to your business. And if they're new to your business, it means that you could take existing interactions of customers that are highly engaged, that are already on the right revenue curve, and you could then recommend things to them to do. So those recommendations could be actions, or it could be, a nudge to buy a product, or it could be, a nudge to get them to invite a friend to participate in what they're doing with you. And then we see the 4th stage is the kind of continuous maintenance, So and I think that what happens sometimes, you almost need to see churn as that 4th stage, because once people have been with you for a while, they get bored. You're highly deliberate. You've turned something that's supposed to morph into somebody's personality into a rule where the rules might apply somewhere else. And you don't have a way of engaging in a way that is more humanistic. So that means you want to test more options and variety and calculate the value of them being with you and so on. So I'm not sure, how do you see it? Do you also see it as like nudges on the one end could be for product, but the other end it could also be for actions or for behaviors, generically?
Well, call it what you like, customer stickiness. But, if you're using real-time behavior to be relevant to the customer, that's going to create some sort of stickiness, loyalty, lifetime value, whatever you want to call it. And right now, customer loyalty kind of is not that huge at the moment, and I think there's so much competition with everybody at the moment. If you can come up with some sort of differential that builds customer loyalty, to prevent them from ever churning, then I think you've hit it. And if you can do that in real time with maybe some personality stuff brought in there, then that should be a game changer.
Well, but the other thing is, then how do you then decide between real time and near real time?
Well, then maybe it comes back to just its relevance. How relevant is, if 3 milliseconds or 5 seconds. I mean, I think it matters. It depends how grumpy you are. Maybe it depends on the personality of the person.
I have a quick question around that, and that is, when you say real time, do you mean in process? In other words, that somebody who's part of an interaction like support staff or something, they're actually waiting on an answer? Because there's a difference between like being able to act quickly, and I mean, a lot of the real-time systems that I've built, the speed at which you can respond becomes incredibly important, because people actually look, even your staff members are looking at the screen going, oh, my computer's very slow today. Okay, like meanwhile it's done 100 million like calculations in the background to figure out what to tell this person to do. I mean, okay, it's a long-winded question, but are we talking about in process, or are we talking about near real time?
But you see, that's, I think, isn't that then the overriding debate? Maybe just to step back from that. Last week when we spoke about the concept of time and why it is so fundamentally important to kind of flesh out your philosophy of time, firstly, and secondly, the view of how you're going to take time and translate it into your technology, is that you might in some cases deliberately delay an interaction to drive customer happiness. And in other cases, you want to be deliberately and intentionally, in motion or in execution, from a timing point of view, you want to be immediate with the feedback or the interface that you give. So I think that sometimes the big question, isn't it, is that do we just make this generic and say that everything can be real time, or do we decide that some part of that human in that system that might require certain kind of treatments or certain kind of responses to actions. You need to understand what it is that is important to them before you agree on real time that might be immediate, that means within milliseconds, or somebody who you're going to wait minutes, seconds, a week, a month. When do you decide to wait or not? So could you say that if you have a weekly recommendation that goes out to your customer base, that it's still considered a real-time problem?
You see, I wouldn't count that as real time. That's out of process as far as I'm concerned. What I'm thinking about is like when somebody's interacting with a website, whether it's a staff member or a person, and you've now got to take a few milliseconds or a few hundred milliseconds. You know, I'm just drawing a distinction.
Yes. But then the thing is, and I mean, Richard, this is probably the bigger question for us, is that what if we know that the ritual of a person's interaction throughout a day means that they will only really be open to us giving them a recommendation or involving us in any of the things we're going to recommend by the time they get to middle of the day when they have a break?
Okay, but you can't sell food after lunch.
Yeah, exactly. But that's the point, isn't it? So that means that if something is going to happen during the day or at the end of the week, would your real-time capabilities still be necessary for you to be able to do that? Because if you think about it, if something is going to happen on Friday this week, and you know that it has to happen on Friday at 10 o'clock this week, is it then a delayed action or a batch, if you think about in a machine learning or prediction world, a batch job, or is it something that your real-time predictor will stay attuned to, and at that time when it's ready to present something, only then present it?
Okay, I understand that. Okay, because of course the best decision we make is the one that we make as late as possible with as much information as possible. So your real-time predictor, although it's going to run at 10 o'clock, you run it at 1 minute to 10 o'clock for that person, or a fraction of a second before, using everything that's gone before. So it's scheduled, but it's real time. I get it.
So I think that's part of the debate that we're having, I guess, with ourselves at the moment, is just to say, well, how relevant can you become in the context of a human system, and how well can you embed yourself within that world so that you can take the cues that happen throughout a particular life cycle of a person participating in their day-by-day activities, and then have an intervention model that is still real-time, but it decides what it needs to do at the right moment in time.
Can I also just add to that there to say, I mean, perhaps something that's of vital importance as well is how versatile it can be. So to not apply the same treatment to every customer or to every interaction, to perhaps have like groups of people that require different styles of interaction, or as you said, different styles.
Yeah, but I think this is kind of the whole debate. And when we show you the tech in a moment, this is what I want everybody to kind of think about, is that there's a way that we've seen real-time historically, and that is that it is entirely based on a pull mechanism. So that means you wait initially for the human to take an action. When the human takes an action, you know that they have initiated whatever the event is that they initiated. You then, in real time, based on that initiation, go and check what it is that you want them to do next, or what you want to offer them next. You then intervene with that process through your nudging system, and you alter the course that they might take next, or the path that they might take next to get to an outcome. The flip side could be that, with the same concept applies, if you know that you've got, a broad spectrum of customers that you deal with, and a broad spectrum of people that you want to nudge, and you have a way by which you can determine that certain events will come up in their lives that are relevant to who they are. So that means that if you know that they are likely to drive tomorrow morning to a particular destination, and you want to test if they are actually driving, because the destination might be a restaurant that you want them to use your credit card, that you know that when they finish there that they must go, perform the next action. You want to be able to understand those sequences, and that means that you need to be real-time relevant, but you need to fit within that life cycle, so that it's not always being pulled from some way that you can in real time determine what it is that they're going to be doing most likely next. So that's kind of the debate. Is it, how valuable is that? If you had to think of then the construct of your real-time predictor and what it would feel like to have it in real time or not in real time, means that at ground level, you need a base piece of technology that can manage the process for you. So what you want to be able to do is to configure a part of what you want to do that is historically based. So that means on data that you already have about how your customer behaves. And then what you want to be able to do is to use that to train a model and to get it ready and to prepare it in a way that you can then do a scoring mechanism that will help you to understand the real life activity going forward. And at the end of it, you want to be able to make decisions to say that, yes, can I use the same construct if I understand more about my customer's life to intervene when it's most relevant to them. So that means that that ongoing cycle of the technical interface is something really worth thinking about. What I'm going to do is I just want to share my screen and I'll show you something in a moment. Anybody else working on a real-time problem at the moment that is particularly interesting to them?
To be flippant or facetious, Jay, aren't all problems real-time?
It basically is, if you look at it the way we described it earlier, isn't it? Okay.
But Rob, that's actually a very good point, because the reality is, if we worry about stuff outside of the time, we can do something about it. And if we only responded in real time, we'd all be a lot happier.
Eric can just talk to you about this from a concept point of view, and then I'll get into detail. Here's a recommender data set that is used in a particular recommender. And maybe you just want to give everybody a quick view of this data set. It's the one with so what you have is you've got a data set that's got all the base features from a customer and all the offers that they've taken up over time, where you've got them essentially, we prepared them on a distribution so that we could see how customers would take up products in the context of a particular recommender's behavior.
So yeah, this data set is one that we created for simulating recommendation and recommender models, and it has some sort of real-time features built into it. And the idea is, I mean, I don't know if anyone remembers from the recommender discussion that we had, there's a few ways that you can design recommender data sets in the context of having not too many products and quite a lot of data about the user. So this is a situation where it's not a Netflix situation where you have, or Amazon, where you have sort of a huge number of things that you could recommend to a sort of relatively small number of people. This is more of the sort of financial services situation where there's a relatively small number of things that you'd want to recommend, and you have quite a lot of information about people. And the way that this set is laid out is to say that we're going to train it on what was the most recent offer that all of these people took out, and train a multinomial on that to predict which offer they're most likely to engage with. There's a bunch of other ways to do it. I mean, I won't go into it now. We did a whole meetup on it. I'm sure we'll revisit it at some point. But that's the sort of general structure. And the idea is that there are, as Jay was saying, a bunch of pieces of demographic data around things like, number of children, the level of education, all that sort of stuff. And then also some in the data has like real-time features, which in this case is their engagement personality. So the balance is almost a illustration of a incredibly useful, seemingly quite basic, like contextual real-time feature. So often with these recommended, particularly in financial services, if you don't have that real-time functionality, you can recommend stuff to people that they can't actually buy anymore. You might, because it's not there, when you ran your recommender previous night, they had however much airtime or however much money in their account, whatever it was, and that's since changed during the day, and then they get your message and it's now irrelevant. So having that balance as immediately as possible is very useful. And personality also looks at how they've been engaging with that platform, with your platform, to get to the point where you're giving them an offer. Are they in an experiential, explorative mood? they've been looking around, or are they very intentional? They're just trying to get to the point and sort of uses the previous steps in your journey to predict what you want to do next. And I think those two kind of, we speak about, real-time predictions, but I think a key part of that, which comes through, I think, quite obviously in those features, is just the benefit of having the real-time features available as well. It's like a key part of getting the benefit of being able to make your predictions in real time is to have your features in real time too. If you're only refreshing your data in your feature store overnight, then real-time predictions are probably not as useful for you. You need to have, not every feature needs to be real time, obviously, like age. You don't need to update people's age by the day, number of children, although if that does change, it's a very good trigger. But yeah, so that's just at a high level what that data set looks like. Apologies, it took a while to remember which data set it was.
No, sorry, Eric, I just sprung it on you just before this. But what happens now is that you've got a multitude of different ways in which you can train the model. So in this case, there are couple of models that can be trained, and you can even get your recommended to start selecting between them and have different hypotheses. And you also have a real-time propensity model to in real time decide, how and where people, are likely to engage. So you will then set your recommender so that you can decide if it needs to remember what it's given it before. Because if you think about it, in a normal LSTM or a deep learning model that deals with long-term, short-term memory related, kind of functions. What you want to know is that if I'm going to present somebody to something and they purchase it immediately, you want to know that you cannot go and offer them that same thing again. So what you need to do is to maybe pitch the same product until they buy it, or once they bought it, you then switch to a new category. Or what you do is, if they're not buying it, you want to keep on recommending it until you've exhausted what you think the number of options are of presenting it to them. So what you then can do is that you can set it up in a way that you say, I want to present this offer, and I want to use, say, a Bernoulli sequence or some other numbering mechanism to decide that every second, every third, fifth, eighth, whatever offer is something that comes from that comes from the cache, because it's already recommended, and I really want to try and sell this thing to this target that I'm selling it to. And then you can have a multitude of other mechanisms to then guide it in different directions. So there are various options that you can use to configure the kind of entire deployment of how you would get that into a deployment environment. So what I'll do now, I'm going to show you what it looks like on a dashboard. So this is what it looks like when it's in production. So this is an example of that simulation that I ran. So it's running on a local infrastructure. So you'll see that it's only sitting at about 10 milliseconds in response time. Normally this one will be about 2 or 3 milliseconds in response time when you put it into a broader kind of data center or a high performing data center. And I'm going to kick off a simulation in a moment and then show you how we will typically track the various criteria that is normally worth keeping an eye on as you have this kind of environment in production. What you'll see is that some of these panels are empty. That is just because I'm not running the aggregator in this simulation, and there's an aggregator that does throughout a day and a month, whatever. It automatically aggregates your data so that and it works out a number of different kind of distributions, so you can see other analysis. That is turned off at the moment, so you only will see all the real-time responses. Then the other dashboard that I'll show you is the dashboard that is typically used by the data scientist. So in this case, it shows you how many offers are presented and how many are accepted within this particular simulation set. And then the explore exploit is just a very basic way in which you could set, in this example, your multi-arm bandit. And then you want to track model performance, and you want to start tracking this different parts of essentially the different base metrics when it's in production. So you've got so many offers that have been sent out, so many that have been, and you really want to understand the offers plus the scoring of what kind of score is more accurate. Normally, this is purely for visual purposes. You would normally run behind the scenes. There's an engine that will go and calculate this to make sure that the feedback loop happens completely seamlessly. So this was just run earlier from a test point of view. So what I'm going to be doing is I'm going to say I want to track the last 5 minutes, and we're going to keep an eye on it every 5 seconds or so. And when I kick off the simulation, you'll be able to see how that runs. So we're also going to make this the last 5 minutes, and we want to pick up the last 5 seconds of timing. So normally these kind of dashboards will sit on big panels in your operation center or in your CEO's office that's going to want to track, revenue made or whatever it might be, because there are a series of these different dashboards available normally. So what I'm going to do is kick off the simulation, and within 5 seconds, you will now start seeing results popping up. So you can imagine throughout the day, if you've got thousands of millions of people busy using what you're using around the world, you'll be able to track, in this case, it's just tracking the performance coming in. You can see there it's hitting 27 milliseconds because of all the stuff running on this local environment. And if I go look at my scoring dashboard, you can see your initial scores popping in. So if you just, let's say we zoom in on a few of these and you start looking at what it's doing, you can now start seeing that in this case, the explore versus exploit is that it's exploiting obviously a lot more than it's exploring, and that's what you're seeing here. So that means that it's fairly consistent in what it's testing in the context of a client base to what is needed. You can look at the score of the model based on whichever input parameters are coming in. So from a data set that it hasn't seen before. So we just keep on refreshing this. We'll see it will load. Let's bring it back to the last 5 minutes. So you can see that what happens now over time is you can keep on tracking the performance of, in this case, it just shows you that you've got your recommender recommending. You've got the scores of the offers that are going out. You can see that in this, a lot of these scores are sitting at 0.9. So that means that it's recommending items that are already been trained to tell that it's going to be successful. And then you can start seeing which ones have been taken up. Since this is a simulation, you're not going to get a true reflection, but at least you'll be able to see that, yes, like you can see that there's, in some cases an offer that is accepted by somebody with a low score, and in other cases by a high score, because over time, you're really interested in those deltas, because it's going to tell you about model drift and the changes that happen in your data set over time, and especially the client base that this is normally targeted at. But it's also important is to start understanding how the model is distributing the offers and how they're being taken up. So in this case, you can see that in this simulation, it's giving these as offers, and it's accepting it at this rate. So you can see that this product in the green bar, the product 0, by default is the one that is more popular than this particular product. So what you might want to do is to run a separate campaign to have an offer, especially if you know that this particular product is highly profitable or that it's not being used by people that you want to use. You want them to use this product. You want to be able to then provide additional offers, and you want to then skew this data. So that's what we often call induced bias. So you almost want to have bias towards a particular product so you can start tracking, how many people are taking it up. So at the moment, there's no caching turned on. So that means that we're not remembering anything. So we keep on recommending new things all the time. We're not remembering any old product. And you can then just, again, look at the difference between, for this particular customer number, what the typical score is, and then how many of those they've accepted. And you see in this case, the acceptance this gives you a 1.0. It's kind of how the graph is configured.
So, Jay, it's Brian. So, if you go to, what do you call them, pizzas and Manhattans or whatever, but if you go to that Manhattan thing, obviously the higher the graph, the better. And then any CEO would look at that and kind of go, okay, green is fantastic, and he knows what the green is. It's product X or whatever.
Yes.
Are you then able? So let's pick a retailer, and a retailer is maybe he's got a whole lot of stock that might be becoming old or redundant, whatever.
Yes.
Okay, you could use your clever software to launch a promotion or whatever on that particular product. Yes. In real time, and get the oaks, put it on discount or whatever that you can do.
Yes, definitely. Yeah. That's exactly the case here. So what you could do, there's another feature, what's called a budget, or basically it's a matrix tracker. Some clients call it a budget. And what it does, it can track across multiple dimensions the criteria of that product being recommended. So you can create an induced bias. You can keep on, push that product to a certain segment, to a certain geography, to a certain group of people. And then what you can decide is that if it hits a certain threshold, you want to provide certain discounts up until the point where you don't want to provide anymore. Yeah. So that can be dynamically configured. Yeah.
Sorry, that can be done in real time.
Yeah. That's all done in real time. Everything. Okay. So that means you can have loyalty calculations in real time, pricing adjustments in real time. And in this case, this one doesn't do much of a pricing adjustment. You can see it sitting around 10 milliseconds in a current simulation on this local desktop. So when you run this in a data center and you've got a complex case, we find that complex cases on our desktop, our desktop test environment, we call it, will normally run at about 35 milliseconds by the time it hits, in company data center, it sits at about 7 or so milliseconds. So that means you can still do real-time, loyalty and interfacing and all kinds of additional calculations while producing that result in a very short
and if
space.
you've got like 100 items left, can you induce whatever you call it, 100 items, and then you switch it off?
Yeah, so what you do is you can take your total, if you have, say, a total stock base, and you want to flatten it all out. What you do is you take your most slowest moving items and you want to prioritize those maybe initially first to get those out the door, because the fast moving is going to move fast anyway.
Yeah, correct.
Then what you then do is that the recommender, every time that it decides on the explore exploit, will keep on deciding on the explore that it must keep on exploring the items with bias, the items that you are disproportionately giving it a weighting to because it's not selling those just yet.
Okay.
But you don't want to just sell only that for a period. You want to split it throughout the period. So you can decide that you run 2 overriding time campaigns. One is for a short period, so that could be an hour, a day, a week, whatever. And then you have one overriding that runs, say, for a week. So you can have your fast-moving items that you always have in stock as your overriding campaign. Yeah. And your detail campaign could be on a daily basis. And especially, I think, for perishables, maybe, something like that. So if you got, and you really want to get rid of them and you want to go and target, say, you're in a city block, whatever it is, and you want to push out messaging to people to say, listen, can buy your bananas today and you're going to get a special, because that you're not going to be able to sell them anyway, then you can run that, definitely. But that will then pop up on here. What will happen on your dashboard then is that you would have a number of models listed here. In this case, you see it's running off one model. This is kind of one model to this. This is a out-of-the-box picture, but you would have a stack of models over here. We also got versions of this dashboard that deals with, especially if you've got like 15, 20 models, to start comparing the models only and their performance, and then you can come back to this, to any of the other kind of detail.
And can you configure these dashboards to be as user-friendly to each customer or customized per customer? How?
Yeah, completely. I mean, this was done as a generic product, and I know that when I saw what this looks like on, some client sites, it looks very different now. I mean, they've adjusted this quite a bit. If you think of like this one here that shows you the performance, over time, what a lot of clients have done is they've taken this top dashboard here and put it in the command center. Sorry, it took a while to show up on it. You see this one here, it took a while, at least they took these and put it into the command center, and they take the detailed, items, the performance related criteria, and then show that to the people who analyze, in this case, like the API performance or the feature store. So like in this case, you can clearly see that if you had to take the API out of the picture and you look at the feature store performance alone, that's where most of the performance, kind of sits in most of these predictors where there's no caching, but you can see that it's hitting around 7 milliseconds. So that means that a big part of our dependency is the data engine that we've got to make sure that it can read that velocity of data the whole time and then make sure that it can make the recommendations. Yeah. So these are very crucial graphs to track over time. You can also see that on this port number here, what a lot of clients would do, this is an example of showing if you say, 6 horizontally scalable scoring. This 6 horizontal scale means that you can put 5,000 transactions a second or maybe even more through this, including with the API and overhead with that. Yeah. Basically, this is what, if you had to think of people out there on their devices getting recommendations throughout the day or buying, if you had 100 customers, then a lot of what you see here is not really going to be that interesting. But if you sit with, 1 million, 2 million, 20 million, 55 million, or some clients, 100 million customers, then it changes the game entirely, because that means that you really want to understand through your entire geographical spread of your product where things are being sold and how, and then know how you can then, act on that.
I mean, it's incredible. I just think the ability for you to nudge anybody, while he's active on a customer and nudge him in a direction that, force feeding him almost. I mean, I think that's just unbelievable technology. And I don't see that happening at the moment. I do online shopping and 60/60, et cetera. I'm not getting nudged at the moment, to do anything. Yeah. I mean, I think this would be a complete, as I called it, a game changer.
Yeah, and I think what is, great for people who get involved with us now, obviously, if you think about our early days, this is our 3rd generation scoring engine. So that means it's gone through 3 entire rewrites just about. We're working on, obviously, designing the future now of what the next one is going to look like with a whole new bunch of features around additional reinforcement learning beyond what we have now already, and additional mechanisms of doing real-time testing and the like. And that just means that this ongoing matching of making sure we've got dashboarding that can show what actually happens, because most of what we do, you can't see, you know what I mean? It's kind of bolted into the fabric of what you do. So that complicates it sometimes, because so how do you demonstrate this? So we actually in conversations with, companies at the moment to find ways in which we can create demos or a visualization to show this is physically what it looks like when you use it, because otherwise you have to go to, like Vodafone or whatever it is and go play with the app, and then you can get a feel for the demo.
Yeah.
But the idea would be to have kind of a full, kind of like a visualization of seeing exactly how the recommenders shift.
And preferably with their data.
Yeah.
Yeah.
I mean, the thing is, we want to create, what we're working on at the moment is, an approach to have this whole stack into like a demoable container, so that somebody can go spin up and say, well, this is what a recommender can do for me, and let me go and try it out and go tweak some of the details myself. I mean, that's kind of the focus.
There was just a comment from Jacques who said maybe like a salesperson responding to real-time customer behavior.
We are in conversations now with, in actual fact, with a big global outsource company, is to figure out how you can bolt the personality recommend and everything into like an agent-based system. So you can have either human-facing recommenders or you have customer-facing recommenders. And the idea is that you should be able to get that salesperson that is either face-to-face or digital, to get an action recommended to them, and then keep on testing it throughout the day to see if it's working with it. Because in this example, what happens is if you want to know how much money you are making or losing, all you have to do is turn off the recommender, because you can clearly see, like in this simulation, what money you were making by this particular recommender running. So that means that there's a distinct line that you can draw, because there was an era before you had this, and let's say it was human-based or current campaign, and you continue with your current campaigning. Then what you then do is you implement a case like this, and you then bolt it in, and you start doing it in parallel. And whatever money you're making here is essentially like a sales force that's automated in its entirety, and you can clearly see what it's worth to you, because if you did not have it, there would have been no money whatsoever. So you can start filling in gaps in the market and start selling in areas that in normal conditions you would not be able to do. So it's quite vivid with what you can then track from a performance point of view.
Yeah, just one quick question on that. I mean, if you've got these recommenders, in place, you don't want to be turning them off to see whether they were working or not. How close to, canary deployments and blue-green deployments is the system?
Yeah, listen, we've tried all sorts of mechanisms, and I think that realistically, the only way to know that you're alive is to stop breathing, isn't it? So that means that, if I can use that analogy, so what we've done is we run, and if you look at in this environment, if you've got 8 running, and you know that you've set up some of them to only focus on certain segments or whatever it is, the only way to do the testing is to sometimes during the day turn it off for 5 minutes, turn it on again, and track those deltas, as like a set analysis. I'm not sure if there are, how else would you truly know that it is, doing what it's supposed to do, that it is contributing the way that it's supposed to contribute.
I have a quite a simple recommendation in that respect that I've seen done in a very large payment processor, and what they do is work on the last digit of the customer ID. Okay, so they can deploy new code or new something to 10% of their customers without really doing much in the way of coding, because they just base it on the last decimal.
Yeah, no, there is a standard practice. So it's not just about the last digit. You can pick all sorts of groupings. So no, we do that, but realistically, even within that grouping, you still want to do the control test. So that means the only way that you truly know that something is going to have an impact is by not having it and then having it. So you'll see that, Spotify and Facebook and all the global, even kind of digitally focused companies all do tests throughout the day by turning things on and off. Just that if your base is much bigger, you just do it for control groups, for smaller groups, and you do it for shorter periods of time, especially if you've got high volumes of activity. So an example is that if this was for something that has got to do with selling cars, you normally would not typically run these kind of tests. But if you sell high volume items at lower prices, then it is fairly easy to do that, because you can then see, where the impact's going to be. But I mean, yeah, that's definitely an ongoing interest of ours, is to figure out how you can truly measure that impact. Because in this case, the impact is just, if you run this in parallel with your existing campaigns, when this goes down, whatever revenue shows on your revenue line, if that's not there, you got nothing, because this will perform its own set of actions. So that means that you don't have to turn it off, because you know that while it's running, it runs in parallel. If it does not run and it is your primary channel of recommendation, then the only way to know is to then take control groups off your stack and then measure them in the time delta between what's happening today and before. So yeah, I mean, there's probably a few ways in which you need to think about that.
Interesting stuff. And of course, you've got to make sure it's at the right time of the day or the right time of the month, the right time of the week, and all the rest, so that you're comparing apples with apples. Yeah.
Listen, exactly. And that's why, if you think of something like banking, telephony, retail, anything, insurance, any of those sectors, most of what you do will have a high impact on the time of the day when you do that. So if you want to know if your lunchtime campaigns are working in selling insurance, the only way you're going to know if it's working is by turning it off on one segment and not another, or one control group and not another. So that's an ongoing, it is tough to find the right balance to figure out if it is really contributing.